Hey guys, today's topic is muscles. So everybody knows that muscles are responsible for most of the movement that we produce, and obviously they look pretty good too. That's the reason that a lot of people are working out. Today we're going to go into kind of the muscle movements that kind of define our human movement, as well as on a cellular level what's going on behind a muscle contraction. Okay, so Rye's going to show us the microscopic view of everything first.
All right, guys. So over here, it's just your standard muscle, right? You got the muscle belly, all the fibers and stuff, and then the ends, the tendons, which are going to be attaching it to the bone, right? So if you cut a muscle in half, it would really look like this. So there's going to be a bunch of bundles, like big circles with tons of little fibers within. So these big bundles are called fascicles, and within each fascicle are the individual muscle fibers or muscle cells, right? So attached to a certain amount of muscle fibers are going to be nerves, right? So these nerves are going to conduct the impulses which tell the muscles to contract. But like, how do they actually contract? Well, so at each motor end plate, there's going to be a release of acetylcholine into the muscle fiber itself. This will trigger a release within the cell of calcium, and that calcium is going to interact with the individual filaments within each muscle fiber, right? And so, like I said, like these motor end plates, is like each nerve is going to be attached to a certain amount of muscle fibers, and that's called a motor unit, right? And so a motor unit can either be big or small based on how many fibers it innervates, right? So if it's attached to a bunch of muscle fibers, that's going to produce large movements, right? So like big gross movements, gross motor skills, right? And then small motor units, so one nerve connected to one or two muscle fibers, that's really specific, right? Because it's just telling those single fibers to contract. So that's going to be for fine motor skills, right? So like dexterity, things like that, okay? So the filaments are the things that are actually contracting within the cell. So this right here is a diagram of the filaments within each muscle fiber. So what happens is the calcium comes in, it's going to bind to this little purple guy right here called troponin. That's going to release off of the rest of this chunk, which is the actin, and basically it's going to rotate the tropomyosin, which is these little blue lines, and that's going to expose the actin to the rest of the cell, which when exposed, the myosin heads actually move out and like Velcro grab on to the actin filament, right? And that creates this cross bridging, and that in turn shortens the filaments and brings them in towards each other with shortening of the A band and the I band. And that's how you get your contraction of the cell, right? So the cells are actually moving in and out just like that.
That's a really good explanation of microscopically kind of what's going on when you contract a muscle or you're lifting, whatever it is. Over here we have a little bit more zoomed out, more macroscopically what's going on. So there's three types of muscle contractions that we're going to talk about today. The first is an isometric contraction, which basically means, and this is an arm right here if you couldn't tell, basically means the external load is matched by the load produced or the force produced by the muscle, meaning that this dumbbell isn't going anywhere. It's going to stay right where it's at because the loads are matched. Okay, so it's just like this. Okay, that's an isometric contraction. Second is a concentric contraction, meaning that the muscle producing force, the muscle is going to produce so much force that's going to overcome the external load of the dumbbell, meaning that my bicep is going to shorten and concentrically contract. Okay, that's kind of typically what you think about when you're working a muscle. You think about a concentric contraction. That's what that is. Lastly is eccentric contraction. This is when the muscle belly is actually lengthening. Okay, just like Rye showed us there, and basically the external load is greater than the amount of force that's being produced by the muscle. So it's pulling my muscle apart like this, but it's still considered a biceps eccentric contraction. And we're referring to the biceps here, just as an easy example. So throughout our programs and throughout a lot of strength and conditioning programs, you're going to use eccentrics, isometrics, and concentrics to train different aspects of a lift or a movement. And actually within the rehab kind of world, there is a lot of transfer of, especially isometrics and eccentrics, for things like patellar tendinopathies or tendinitises, things like that. And basically it's used as a really good rehab tool, and we're going to cover that in some future videos, but we're kind of just dropping hints at you now, and we will fix that later, kind of.
Alright guys, so that's pretty much a basic overview of how muscles work, you know, and how your body moves through space. It's all based on the muscle pulling on the bones within your body, driving locomotion, you know, whether it's from your legs, your arms, all the muscles, that's all muscles do, is just pull on bones and drive motion, right? So if you like this little description today, go ahead and like the video, please subscribe to the channel, and we'll see you guys next time, all right? Thanks guys.